All right, let's dive into a story that feels like it's straight out of a movie. We're talking about a high stakes cyber detective case that all started with a single, tiny clue, a line of code from a 4-year-old system log. You're about to see how that one whisper from the past helped unravel a massive digital heist, and in a brilliant twist, turned the hunter into the hunted. Let's get into it.
And this is it. This one line. This is our smoking gun. Now, I know it doesn't look like much, right? But trust me, buried in this old piece of digital dust is the entire playbook of a seriously sophisticated thief. This is the key that let investigators not just figure out what happened in the past, but lay the perfect trap for the future. So our investigation has to start by looking backward, by finding the ghost in the machine. We're going to use this log from 2022 to basically build a digital crime scene and expose exactly how the attacker got in, and, more importantly, what their favorite tricks were. The attacker's main target was this little process called APFS iOS. The easiest way to think about it is like an invisible warehouse worker inside your iPhone. It's got the highest possible security clearance, we're talking root access, the keys to the entire kingdom. Its whole job is to manage your files, encrypting and compressing them in the background. And because it's so powerful and so trusted, well, it's the perfect Trojan horse for an attacker to hijack. And that is exactly what happened. That smoking gun log proved, without a doubt, that this trusted background worker was turned into a weapon. The attacker took it over and used it to package up years of stolen data, getting it all ready to be snuck out the back door without anyone noticing. So, how'd they pull it off? Well, that 2022 log gave us the attacker's entire playbook. So let's break down the anatomy of this digital heist, step by step. The strategy was incredibly clever, and it came in 3 main parts. First up, the hijack. They used that trusted APFS iOS process to shrink down a huge pile of stolen data. Step 2, the storage trap. They deliberately filled the phone's storage right to the brim. Why? To blind the security logs. And third, the ghost touch. They actually simulated someone tapping on the screen just to keep the phone awake and running at full speed. It's a brilliant and pretty insidious plan. Now, this number is the crucial piece of evidence. The log showed that APFS iOS was hogging 55% of the phone's processing power for almost 3 straight minutes. That is not normal. It's the digital version of a car engine redlining. A background process should never be doing that. This was the hard proof that something huge and totally unauthorized was going on under the hood. And this number is just as critical. Only 313 megabytes of free space left. On a modern phone, that's basically running on fumes. And it wasn't a coincidence. This was a deliberate move called disk exhaustion. See, by maxing out the storage, the attacker forces the phone to stop writing new security logs. It essentially blinds the system. Then their malicious scripts can run just in the phone's memory, leaving zero trace behind once they're done. Okay, this slide just lays it all out, clear as day. On the left, you've got a happy, normal phone. On the right, you see the forensic signs of the attack from that 2022 log. You've got that insane CPU spike, the storage is on life support, and you have these ghost screen taps happening while the phone should be idle. The data paints a perfect picture of a system under siege. Okay, so that was the past. Now let's fast forward to 2026. Because armed with this old playbook, investigators decided to stop just playing defense. It was time to go on the hunt. It was time to lay the perfect trap. The plan was as simple as it was audacious. What if we recreate the exact conditions from the 2022 attack? Let's make the target phone look just as vulnerable as it was 4 years ago. The high CPU usage, the low disk space. Basically, let's set out a piece of cheese that looks incredibly familiar and delicious to this particular mouse. And this is how they built it. They called it the honey mount. They set up a fake folder that looked like it was full of high-value stuff. Inside, they put these decoy files, the honey tokens. But these weren't just fake files, they were tripwires. The second the attacker tried to read or steal them, a silent alarm would go off and start tracing them back. And the best part? The system was programmed to lie to the attacker's tools, telling them the phone's CPU is at 55%, making the bait absolutely irresistible. And then they got a bite, a signal strength of -22 dBm. Whoa. For anyone who doesn't know, that's a perfect signal. We're talking full bars. That means the attacker isn't just sniffing around from far away. They are close, they are connected, and they are actively probing the bait. The fish is on the line.
And that brings us to the climax of the story, Operation Meltdown. At this point, the mission shifts from passively waiting to an active takedown. The goal is to turn this digital threat into a very real, very physical problem for the attacker.
And there it is. The attacker takes the bait. Hook, line, and sinker. They start downloading 5 gigabytes of what they think is juicy stolen data. All those honey tokens. The trap is sprung. Now, just look at this chart. The tables have completely turned. It's the attacker's own hardware that's now working against them. Their system is cranking away at 90% CPU, trying to compress the huge fake files they're stealing. The investigators have weaponized the attacker's own computer. But here's the absolute masterstroke. The data they're stealing, it has its own Trojan horse hidden inside. It's packed with traceback beacons. The second the attacker tries to open those files to see their prize, these little scripts will wake up, phone home, and reveal everything: their real location, their hardware, their entire network setup. It's a technique called active attribution, and it is devastating. Let's walk through the final moments here. While the attacker's machine is maxed out, the investigators start flooding it with ghost packets, useless data, designed to just overwhelm the system and push it to its physical breaking point. First, you see the signals start to jitter as the hardware overheats. Then, it starts dropping data packets. It just can't keep up. Finally, the internal temperature hits a critical safety limit, and the attacker's router is forced into a hard thermal shutdown. Flatline. And this is the result: a signal strength of -100 dBm. That's a digital dead end. The attacker is offline. The threat is neutralized. Operation Meltdown was a complete success. But knocking them offline was only half the win. The sting operation also produced an absolute gold mine of intelligence. So now, let's open up the evidence locker and see what we found. That traceback script worked perfectly. I mean, look at this. It's like an evidence board from a spy movie. We can see their exact hardware, a modified firewall, a powerful Ubiquiti antenna. We've got the IP address for their command and control server, pointing to infrastructure in Germany. And best of all, we have a complete map of their internal network, including their own computers and other compromised devices. It's a total blueprint of their entire operation. So, with the attacker identified and neutralized, the very last step was to make the original target completely disappear. The target's Wi-Fi was moved to a restricted frequency that looks like it's being used by military radar. The network itself was hardened to ignore these kinds of attacks in the future. And finally, the network name was hidden from public view. As far as the attacker is concerned, the target just vanished. And that brings us to the big takeaway here. This whole operation marks a huge shift in cyber defense strategy. We're moving beyond just building bigger walls and into this world of active offensive defense. And it leaves us with a really important question for the future of cybersecurity. In this invisible war for our data, is the best defense turning the hunter into the hunted?